supposed to be recording this. So you don't have to use full strength bleach to do a good job disinfecting. 10% is cheap and effective as a good disinfectant. Our next category is a set of chemicals called phenolics. Phenolics, and if you've got the pictures, you could draw a circle around this. Chemically, this is a phenol ring, and this is the most active part of the chemical, and that's kind of what defines a chemical being a phenolic, is it has this particular chemical group. Phenolics include Lysol. So the chemical Lysol is a phenolic chemical. Phenol, which you may have used in chemistry and was a very old-fashioned surgical antiseptic, burns like fire if you get it on your skin, but that was one of the first surgical antiseptics, not anymore. The phenolics disinfect. They are largely going to be disinfectants, and they specifically act on proteins. So they disrupt protein structure. They reliably disinfect, not really sterilize. The other one, you should write down this chemical also, because you will use that some in a hospital setting. As like a high strength disinfectant for hospital beds and the call button, things that people touch, but it's not part of their body. So phenolics. Third group is alcohols. This one, like, people are kind of familiar with what this is. This would include isopropanol, or what we refer to as rubbing alcohol. And technically any other kind of alcohol that's in a high percentage. You ever watched the old Rocky movies? Not Rocky, Rambo. Get mixed up. Rambo movies is what I mean. Or see a movie with a soldier out in the jungle and they have a wound and they pour bourbon or something. Like that is kind of, that's going to work if it's a high percentage alcohol. Isopropanol or rubbing alcohol is just pretty pure and it doesn't have sugars in it or other acids or contaminants like you would with alcohol that you drink. But all of the different kinds of alcohol are going to affect proteins in the microbe or in any other cell. They also disrupt the cell wall. They got multiple targets. And isopropyl alcohol or rubbing alcohol is particularly useful for antisepsis. The other types of alcohols technically will disinfect, but we don't tend to use them on the skin because they have a lot of other chemicals in them besides alcohol. Before I came to King, in the microbiology lab, they disinfected benches every day with alcohol, not bleach. And I switched to bleach because it's cheaper. I kind of like the smell of dilute bleach. It means disinfectant. Next group is particularly one specific thing, which is hydrogen peroxide. Back up and right on alcohol, it disinfects. Alcohol disinfects, not so much sterilized. Hydrogen peroxide kills living cells by generating reactive oxygen species. So when in lab, we've been using this, maybe you even use this week to do catalase testing to see, oh, if I drop this on my bacteria, is it going to bubble and produce oxygen? And show that it has catalase to help resist hydrogen peroxide. The bad news is that if you put hydrogen peroxide on an organism, even if it has catalase, you're going to overwhelm the catalase and you're going to kill the cells, whether or not they have catalase, if you're using that much. So there are no living cells out there that are resistant to survive high levels of hydrogen peroxide. And this includes our own cells also. So when they say that hydrogen peroxide would kill living cells, that would be bacterial cells or human cells or any kind of cells. I'll come back to that in just a minute. Hydrogen peroxide will sterilize. It is a sterilant chemical if you use enough of it. So if there's like a perfect chemical method, it would be hydrogen peroxide. It's cheap. It sterilizes. And we use it for antisepsis also. And probably all of you have had hydrogen peroxide used on you at some point. So if it kills our cells, how are we using it on people without them being harmed by this? How's that work? Where's the last place that you used hydrogen peroxide on yourself or on a person? Your knee? Did it hurt?
I did it on someone else.
You did it on somebody else. Did they scream? Were they a child?
No.
They screamed and they were not a child. So you can pour it onto a cut or swab with it, and you're doing that to kill the bacterial cells. When it hits your living cells, it's also going to kill them too. But we're trying to reduce the infection. If you put peroxide, say like you have a cut on the back of your hand and you put peroxide on it, it's going to kill the bacteria, it's going to kill some of your cells. And a lot of your cells that it's touching it's already dead skin cells anyway. Like, what about if you swish it in your mouth? You ever heard of that? You can afford to lose a layer of cells out of your mouth. It also will whiten your teeth. What about full-on drinking it? No. Like, I heard some people are trying to do that for COVID. That's too much. Like, that's too much. And that amount, if it goes down your throat and destroys a lot of living cells down your throat, that would be bad news. The other important thing about hydrogen peroxide to know is that it breaks down pretty quickly. So that's another reason why it can be good to use it on people, because as you're swishing it in your mouth, it's already breaking down. And it's always in a brown bottle because light helps it break down more. You keep it in a dark bottle. And if you're going to use it for antiseptic purposes, you should buy a new one every so often. They cost about $1. It's the perfect chemical. Okay, next one, aldehydes. Aldehydes. There are two major forms of this that people tend to use, which are formaldehyde, like old school dissections or storing organs in jars. That was using formaldehyde. And there is also a version called glutaraldehyde. Glutaraldehyde that tends to be used more recently medically. We don't so much use formaldehyde anymore for dissections. We do use glutaraldehyde sometimes for modern medical use. Both of these are pretty toxic to humans. And both of these can sterilize. We don't really use them antiseptically very much unless we're just totally sure that it's only on dead skin, like only on unbroken skin. But they do sterilize. They're pretty toxic. And their action would be on cell wall membrane, actually all of the things. They are toxic to all of the different processes. Okay, next one. This is another one that has to do with a very particular chemical. All of these others so far have been liquids, so they would fall into the liquid category. This one is a gas, and it's a particular gas called ethylene oxide. Ethylene oxide. It sterilizes, and it's very toxic, but it has a very particular use for a particular situation. So this equipment that's up here on the screen is an endoscope. And maybe some of you have experienced an endoscope. I hope not. This is one of those. There's a camera on the end of a tube, and you can snake it down someone's throat and look around in their GI tract and see what's happening. The same type of thing would be used for colonoscopies, just going through the other end of the digestive tract. So this is, pretty advanced equipment, and you can't wash this. And you could, it would break it. It would be like trying to wash your phone. It's delicate, it's expensive, it's got meltable plastic on it. So something like an endoscope, you can't wash it, you can't immerse it in anything, and you can't even get it that hot because it would melt the plastic components. But you're sticking this into human bodies that have a lot of microbes and cells and secretions and so on. So the best option for sterilizing advanced technical equipment is to put it in a chamber. You're gonna love this beautiful chamber I'm drawing right here. Here we go. Here's the endoscope. You put it in a sealed chamber and you flood the chamber with ethylene oxide gas, and you let it sit there for a certain amount of time. You are gassing the microbes on this equipment, the toxic gas, instead of trying to wash every nook and cranny of this device. I mean, I think you would kind of remove and wipe down the snake part, but the crevices, the gas is for the crevices. So that's a very particular use of ethylene oxide. This is not a thing that the average person can go out and buy and use for themselves. It's hospitals and it's industry and research labs maybe would have access to this. If you ever work in the hospital and you are involved with processing these, it is very important to do that correctly, because there was some medical worker in California that was supposed to be cleaning colonoscopy endoscopes, and he did not do it correctly, and a lot of patients caught diseases from dirty endoscopes. It is not only disgusting, it's just like life-threatening. So when you go and become a medical professional, all of those annoying cleaning rules, you got to do it. You got to do it right. You got to fill out the tag correctly. You have to verify, yes, it's sterile. So it's also really expensive. Like, you wouldn't want to use this unless you're trying to maintain the also expensive equipment that you're using it to clean. So stuff like surgical robots, you need this. I don't know, like all that stuff that some of those things, like the cameras they probably get ethylene oxide sterilized. So we go from like the super advanced now to the super basic group of chemicals, which are some of the oldest used chemical control methods by people in the history of humans. And soaps would be the oldest. People figured out how to make soap over 1,000 years ago. And then come detergents, and then more advanced set called surfactants. All of these have in common that they have a hydrophobic end and a hydrophilic end. Whatever is comprising them has a hydrophilic end, which they're showing here as a square, and a hydrophobic end. And their usefulness is that they can disrupt membranes. And basically dissolve membranes. You could kill a protozoan with soap, because it doesn't have a cell wall, it's just got a membrane. So if you had the cat feces Toxoplasma gondii on your hand from changing the cat box, soap and water is going to kill it and wash it away. Soaps would dissolve the membrane around COVID virus. If the membrane is inside a cell wall, that's going to keep the soap out. So we can't kill E. coli with soap, but it will cut down the numbers and it'll help it remove things from our hands. These disinfect or decontaminate, but they don't really sterilize. They are cheap. They are basically pretty non-toxic. They might differ in their strength. So, like, you don't want to wash your hands with Dawn dish soap unless you got no choice. You just need a tiny drop. Otherwise, your hands are going to dry out, crack. But they differ in their strength. They're all using the same basic type of chemicals. I want to, got a little bit of time. I want to scoot backward in this and go to show this Mrs. Myers stuff. So this is actually what I use at home on everything except showers, tubs, and toilets. I use it on the counter also. This has in it soap and alcohol. And that's good enough to do your basic cleaning around your house. Tubs, for my house, tubs, showers, toilets, way far ahead. I'm using a combo of halogens and bleach. You can clean a toilet with soap and water if you're real eco-conscious and crunchy. Like, you can, and scrub with the brush. It's kind of a personal philosophy. We don't go eco-friendly in the hospital. So when you work in a hospital setting, there are going to be a lot of disinfectant and sterilant chemicals because people's health really depends on it, and you don't want it mostly clean. And then we come to another very ancient one and very, very cool concept that I did not know about until I started teaching this class, but then it made a lot of sense when I read this, which is metals. And I'm not writing every single metal in the world up here, but these in their solid metal elemental form inhibit microbial growth on their surfaces. And the reason why this has to do with their arrangement of electrons and how their electrons are interacting with the electrons touching them. So imagine this, like back in the day, you know, someone like King Solomon or King David, and they're drinking out of the silver goblet. The goblet itself is reducing the microbes inside of it. That's just cool. If you have metal fillings, I just licked mine. Did you see that? I got one up in the top. You can't see it. And Joseph's getting one this afternoon. He's really dreading it. So, but then we're going to go Speedway and Lights. So I hope that takes the sting out of it. But if you got a metal filling, the filling itself will prevent bacteria from growing on it. Old school brass doorknobs, which is a mixed metal. Brass is a mixture, but it's still metallic. Those prevent microbes from growing on it as well. And that's cool. A metal surface is going to reduce microbial growth. Aluminum is not so much, but what we think of as the heavier, more precious metals would reduce microbial growth. What I will, so to kind of reiterate in this section, the way that I put this on the metals disinfect, they don't sterilize. I add that note. The way I ask this type of stuff on the exam is I will give you a scenario. It's like 2 or 3 scenarios, and I describe, okay, you need to disinfect or sterilize or decontaminate this particular item, and this is where you are, like you're in the hospital or you're at your house or you are camping or something like that. And I ask you to pick one of the ways of disinfection or sterilization, pick one of the control methods, and explain to me why would you choose that. I think there's a word bank for this. I'll make sure of that before and let you know before the final, but that's what it's going to be. So instead of having you like memorize a lot of this stuff, pick out a way to disinfect, sterilize, or decontaminate that item based on what would be available to you at that time. So please let me know if you have questions about unknowns. And those of you I won't see before Thanksgiving. Have a super great and I hope restful break.
You guys like Friendsgiving Tuesday?
We are cooking.